Hi, welcome to a new video of Chemistry Explained by Cher. In this video, Cher is going to explain the molar volume. We can convert between the mass of a substance and the number of moles of a substance using the concept of molar mass, which has unit grams per mole and a numerical value equal to the relative atomic mass or relative molecular or formular mass of the substance. So, what is molar volume? Instead of molar mass, the new term molar volume suggests that instead of the quantity mass, we are now interested in the quantity volume. And since we know that molar mass tells us the mass of 1 mole of substance, then molar volume should tell us the volume of 1 mole of substance. But why do we bother to find out the volume of 1 mole of a substance? This is because while it is easy to measure the mass of solids and liquids, it is not easy to measure the mass of gases, as a gas usually has a very small mass. Therefore, it makes more sense to measure the volume if the substance is a gas. So, what we want to find out is the volume of 1 mole of a gas. Then, this would allow us to convert the volume of a gas to the number of moles of a gas. The concept of molar volume comes from one of the gas laws named Avogadro's law, and this law states that the volume occupied by a gas is directly proportional to its number of particles. So according to Avogadro's law, gases that have the same volume contain the same number of particles. In other words, regardless of the identity or molar mass of a gas, 1 mole of any gas, be it 1 mole of helium gas, or 1 mole of nitrogen gas, or 1 mole of methane gas, each mole of the gas not only contains the same number of particles, but also occupies the same volume. Now, we want to measure what this volume is, and according to the other gas laws, the volume of a gas is also affected by the temperature and pressure of a gas. So the volume of any gas should be determined under the same conditions of temperature and pressure. We would measure the volume of 1 mole of a gas under room temperature and pressure conditions. And what is room temperature and pressure in chemistry? It is a temperature of 25 degrees Celsius and a pressure of 1 atmospheric pressure. So at room temperature and pressure conditions, 1 mole of any gas occupies a volume of 24,000 cubic centimeter. We can do a conversion between the units cubic centimeter and cubic decimeter. Since 1 dm cube equals to 1000 cm cube, the volume 24,000 cm cube is also 24 d-meter cube. Again, regardless of the identity or molar mass of a gas, as long as this is under room temperature and pressure conditions, the volume of 1 mole of any gas was found to be 24 d-meter cube. For example, 1 mole of helium gas has a volume of 24 d-meter cube. 1 mole of nitrogen gas also has a volume of 24 d-meter cube, and 1 mole of methane gas also has a volume of 24 d-meter cube. Molar volume of a gas has to tell us the volume of 1 mole of that gas, and it was found that the molar volume of any gas at room temperature and pressure is 24 d-meter cube per mole. Here, the table shows different gases. While their molar mass may be different, the molar volume is the same for all gases. So do remember that 1 mole of any gas contains 6 times 10 to the power of 23 particles and also occupies a volume of 24 d-meter cube at room temperature and pressure. After we find out the volume of 1 mole of a gas, which is 24 d-meter cube per mole, We can go on to calculate the number of moles of gas particles in any given volume of gas. We use molar volume to convert between volume of gas and number of moles of gas. Now, let's learn how to perform calculations involving the volume, molar volume, and the number of moles of a gas. Molar volume is placed at the bottom left of the triangle. It has a value equals to 24. Number of moles is placed at the bottom right of the triangle. So to find number of moles, divide volume by molar volume. At the top of the triangle is volume, and to find volume, multiply molar volume with number of moles. When doing calculations, it is important to match the units. Since molar volume is in demeter cube per mole, the volume needs to be in demeter cube, and number of moles is in moles. By modifying the familiar DST triangle, we now have a new molar volume triangle to help us calculate number of moles or volume. Time for a sample question. What is the number of moles in 1.2 demeter cube of neon? Do you know what is the information to highlight in this question? I hope you are right. It is 1.2 demeter cube, which tells us the volume of neon. Next, use the triangle to input the known quantities to find out the unknown quantity, which is the number of moles. Time to write the solution. Include a clear statement such as number of moles of neon, which is equal to 1.2 divided by 24, and the final answer is 0.05 mole. The next sample question reads, what is the volume of 3 moles of sulfur dioxide? Do you know what is the information to highlight in this question? I hope you are right. The information to highlight is 3 moles. Next, use the triangle to input the known quantities to find out the unknown quantity, which is volume. For this question, the statement to write in the solution would be volume of sulfur dioxide, which is equal to 24 multiplied by 3, and the final answer is 72 demeter cube. So we can convert volume of a gas to number of moles and vice versa using molar volume, which has a numerical value equal to 24 for unit in cubic decimeter. And that's the molar volume explained by Cher. May you understand and like chemistry more and more.